Okay, everybody. So today we're going to introduce the chapter 1 of the electromagnetics. We will start from the vector algebra. Okay, now I will share screen with you. Okay. Um, so electromagnetics, um, it's it will involve a lot of mathematics calculations, including vector calculations. So it's a good time for us to review everything for vectors. So today we'll first cover the vector algebra. Okay, we will start from the vector operations. I think you have learned this before, but let's review it again. So first, add two vectors. Do you remember how to add two vectors? Okay, now let me change the pointer into a pen with drawing tool. Okay, now I will draw some vectors. So first of all, the difference between a vector and a scalar is scalar, for example, letter A, this is scalar. Um, for a vector, let's say A hat, or with an arrow or hat on the top of um, a symbol, it means it's a vector. The difference between scalar and vector difference is for scalar, it only has magnitude. But for vector, it has magnitude and direction. Uh, so in physics, we will learn a lot of vectors. Let's say in physics, what quantities are scalar and what quantities are vector? Can you name some of them? I will give you some time. Okay. For example, temperature. Is temperature a scalar or vector? It should be scalar. What about force? Is force a vector or a scalar? It should be a vector because force has direction. Temperature, it doesn't have any direction. It's just a magnitude. But force, it has direction. So um, that's the difference between scalar and vector. Now let's do a calculation of two vectors. For example, if I have vector A with a hat on A means it's a vector. And we have another vector B. Let's say B is something like this. What is A plus B? If you want to do the addition of A and B, then we can draw vector A. This is A. And then at the tip of A, let's draw the tail of B and draw the vector B. So this is B. Now, if you connect, create a new vector from the starting point of A and the ending point of B, you will have A plus B. So that's addition of two vectors. And The addition of vectors, it it has some features like uh, commutative and associative. So let's say, what is commutative? Commutative means A plus B equals to B plus A. Why? Let's still take this A and B as example. So if this is A, this is B. So A plus B will be something like that. We first draw A, and at the end of A, we draw the tail of B. That's B. And then this is A plus B. This is A plus B. Now let's draw B plus A. If we start from some point here, let's first draw B. This is B. Then at the end of B, let's draw A. And we start A from the end of B. This is A. And then if you connect the starting point of B and ending point of A, you have B plus A. So from here, you will see A plus B or B plus A. You will have the same vector. So that's commutative. It's A plus B equals to B plus A. Now let's see, what is associative? Associative means if you have more than two vectors and if you want to sum them together, A plus B plus C. If you have three vectors added together, of course, the order of adding them by default is A plus B first, then plus C. It equals to A plus, you first add B and C, and then A plus the results of B and C. That's associative. If you combine the commutative and associative of the addition of vectors, actually the addition of vectors, they are more flexible. For example, if you have A plus B plus C, you can exchange the order of those three vectors by adding other order. For example, it equals to, let's say, C plus A plus B. You will get the same thing. And you can also get even more complicated orders like A plus B first and then C plus A plus B. So that's commutative and associative. Uh, they're very useful when you do vector addition, but this is only for vector addition. It's not for multiplications. Now let's see a little bit about uh, subtraction. So now if you subtract a vector, what should we do? So first, let's see if you have vector of A and you have vector of B. How to do A subtracted by B. First, subtract a vector is the same as addition. The only thing is now you're not adding B, you're adding a negative B. So you need to know what is negative value of vector. Negative, let's say negative B means you keeps the magnitude of B, but changes the direction of B in the opposite direction. So if B, let's say, if B is in the direction of going to the right, then minus B, it will be the same magnitude but opposite direction. It's going to the left. So this is a minus B. Now a subtracted by B equals to A plus negative B, right? So we know how to do A plus a vector, and we know what is negative B. Now let's do the addition. So let's first draw A. And now let's draw negative B, which is going here. This is negative B, and you connect the starting point of A and ending point of negative B. That will be A subtracted by B. Okay, this is subtraction. Now let's see multiplication. Multiplication by a scalar is the most is the easiest multiplication. Let's say if you have vector A, this is A. What is 2 times A? 2 times A. 2 times A means if, because 2 is a scalar, right? If a scalar multiplied by a vector, or a vector multiplied by a scalar, they're the same thing. You will have a new vector which has the same direction with previous vector, but the magnitude will be multiplied by this scalar. Now the scalar is 2. You will have 2 times the magnitude. That's 2 times A, because the magnitude is doubled, but the direction is the same. That's 2 times A. What about if we want to calculate negative? Let's say 3 times A. So as we said, if it's a negative value, means the vector will change its direction to opposite direction. So now A is going up and right. So negative value of this vector will go left and down. So first the direction is going in this direction, and it's negative 3. So the magnitude is 3 times original magnitude of A. So that's negative 3 times A. This is a multiplication by a scalar. The scalar and vector multiplication, it has some features like distributive. What is distributive? Now, let's see. If you have a scalar, I would say A, small letter A, times 2 vectors, the sum of 2 vectors, A plus B. By default, you can calculate the addition of A and B, and then you multiply them by this scalar. However, due to the distributive feature, you can write it in another form, which is A times the vector plus A times B, and sum them up. This is distributive. Distributive is not only for 2 vector sum. If you have more than 2 vectors, let's say A plus B plus C dot 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 plus, let's say, X, then you can distribute this scalar in the way of a times a plus a times b times plus a times c plus dot 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 a dot x. So that's distributive. Okay, now next, let's do the multiplications a little bit more complicated. The dot product of two vectors, like a dot product b, but a and b, they're all vectors. So in the definition of um, dot product of two vectors, it equals to the magnitude of A times the magnitude of B times cosine theta. Theta means the angle between A and B. Now, if this is A and this is B, the angle formed by A and B will be theta. And please notice that here, let me change the color. So here, A and B on the right side of the equation, A and B, they are not vector anymore. They are scalars. So A dot product B, finally, you will get a scalar rather than a vector. Because of the cosine theta feature, you will notice that if A and B, they're parallel, if they're in the same direction, let's say this is A and this is B, if they're both vectors, then A dot product B equals to A magnitude of A times magnitude of B times cosine theta. Theta is 0 degrees because they're parallel. Cosine 0, what's the value of cosine 0? It's 1. So finally, you will get A times B. Now let's see another situation, which is perpendicular. Let's say if this is a vector, this is a vector of B. And if they are perpendicular, means theta equals to 90 degrees, then A times dot product B equals to, again, the magnitude of A times B times cosine theta. But theta is 90 degrees, so cosine theta equals to 0. So finally, you get the answer of 0. So this is dot product of two vectors. When the two vectors are parallel, you have the value of A dot B, or A multiplied by B. It's a scalar. If they're perpendicular, you get 0 value. And okay, now let's introduce a little bit about other features of product, dot product of two vectors. It has the features of commutative and distributive. So first, let's see commutative. If you have A dot B, it equals to B dot A. Of course, um, that's the feature because by this equation, you know, no matter it's A dot B or B dot A, it will be the magnitude of A times B or B times A times cosine theta. And now let's see distributive. If you have a vector A dot product B plus C, and all of them are vectors, it equals to A dot B plus A dot C. Um, so why is that? I'll leave this to you. If you want to demonstrate the distributive, you can do it by yourself. You can use the equation of dot product for two vectors and see if you write it in the two different ways, and finally if the answer is the same. Actually the answers, they are the same. So that's some features of dot product. Okay, here let's go to an example of uh, the applications of some operations of vectors. So first, let's see this example. If C equals to A subtracted by B, let's calculate the dot product of C with itself. So now, if this is A, this is B. So A subtracted by B will be like that. Um, let's see. If you want to calculate um, the dot product of C and C itself, then what you can do is you can write it here. C plus C, C dot product C equals to, because C equals to A subtracted by B, so it's A subtracted by B dot A subtracted by B. And then you can expand this A subtracted by B dot product A subtracted by B. You'll get A dot A subtracted by A dot B subtracted by B dot A plus B squared. So A dot product B and B dot product, these are the same due to the commutative feature of dot product for two vectors. So finally you will get A, B cosine theta. You subtract it by A, B cosine theta twice, finally you will get this. So here, let's notice here, it's a bold A dot product bold B. That means when the font is bolded, it means it's a vector. But here it becomes a scalar. So it's a scalar A squared plus scalar B squared subtracted by 2AB cosine theta. Okay, so this is a law of cosine. Do you remember this law in geometry? If you have a triangle, um, you will have this law of cosine. C squared equals to A squared plus B squared subtracted by 2AB cosine theta. And of course, for any triangle, you will have this feature. This is a law of cosine. Okay, now let's see what's the next. Um, the cross product of two vectors. The cross product is a little bit more complicated than dot product. For dot product, it's easy. Dot product for two vectors makes the result into a scalar. However, for cross product, it's a little bit more complicated. It will generate a new vector. Now let's see, if A cross B, it equals to magnitude of A times magnitude of B times sine theta. Theta is the angle between A and B times n with head. N with head means the unit vector. That means um, the magnitude of n is 1, and the direction of n obeys right-hand rule. Do you remember what is the right-hand rule? I think you have learned it in some other courses. So the right-hand rule is let your fingers point in the direction of the first vector. In this case, it's A, vector A. and curl around towards the second vector, which is b here, then your sum indicates the vector of n, or the direction of the normal vector. So in this figure 1.8, which is shown here, it points into the page. If you times b cross a, it points out of page. Okay, anyway, let's make some examples here. If, let's say, a is in this direction, b is in that direction. So based on your right-hand rule, so what's the direction of a cross b? Because first you will point your fingers in direction of A, and then you curl your fingers to the direction of B. So finally you figure out your sum point out of the page. Okay, this is one example. Let's make another example. I'll draw it on the left. So if you have A here, and if you have B in this direction, so let your four fingers point to A, and then curled your fingers in the direction of B. Then you will figure out your finger is your thumb is pointing into the page. So that's right hand rule. If you have any questions about right hand rule, because we're not teach it in person, so you don't see my hand. But if you have any questions of right hand rule, please send me a comment below the video or send me an email. Maybe I can demonstrate it by recording some more examples with my hand. Okay, this is the right hand rule, and when you do the cross product, you need the right hand rule. Note that A cross B is a vector. So the alternative name of cross product of two vectors is also named vector product. The cross product is distributive. For example, if you have A cross B plus C, it equals to A cross B times A cross C. Okay. It's not commutative because, for example, let's do an example. If, let's say, this is A, this is B, so A cross B, if you use your right-hand rule, A cross B, it results in a vector which is pointing out of the page. But B cross A, it's resulting in a vector which is into the page. So they're completely opposite directions. So B cross A equals to the negative of A cross B, because the direction is completely different. Examples. Okay, so here, let's show some examples. Let's say if I have a plane of x and y and z, this is the coordinates. Now let's say in xy plane, if I have vector of a and I have another vector of b, let's say this is b, they're all in xy plane, then you know a cross b will result in a vector which is in z direction, either positive or negative. Based on the right-hand rule, let's use our right hand first. Let's make the four fingers pointing to the A and then curl the fingers into B. And you will notice that your A cross B, let's say it's C, your C will be going down in the opposite direction of Z. This is the one example. Now let's make another example. X, Y, and Z. If you have, let's say, still A and B, let's say this time, this is A, this is B. They're still in the XY plane. If you want to calculate A cross product B, first make your finger pointing, the four fingers pointing to A, and then curl it in the direction of B. You will find your A cross B or C will go up in the direction of Z. Okay, so that's some examples. Again, if you have questions about right-hand rule, let me know. I'll give you more examples in the future. Geometrically, the determinant of A cross B is the area of the parallelogram generated by A and B, which is shown here. Okay. So in the textbook, it doesn't give you any reason. So why is that? So now let's do it. So why the determinant of A cross B is the area of the parallelogram? Do you remember the equation of A cross B? It equals to AB times sine theta times unit vector n. Now, if you want to calculate the determinant, then the determinant of A cross B equals to, let's ignore the direction and let's only consider the magnitude of the A cross B. That's the meaning of the determinant, sine theta. So the determinant of A cross B is AB sine theta. Now look at this, this figure here. If this is A, that is B. If we draw a line perpendicular to B, but connecting the tip of A to the vector B, you'll figure out what is this dashed line. It's A times sine theta. A times sine theta equals to this dashed line. Or what is that in this parallelogram? It's the height, h, right? Do you remember how to calculate the area of a parallelogram? It's area equals to, okay, area equals to base times height. So here, in this example, base is the magnitude of B. Height is A sine theta. So finally, it equals BA sine theta or AB sine theta. So that's why we said geometrically the determinant of A cross B is the area of the parallelogram generated by A and B because of that. So because A cross B is the area of its parallelogram, then A cross A equals to 0 because the area of the parallelogram generated by vector A and itself, it should be 0. If this is A, if you draw another A, the area is 0. So finally, A cross A is 0. Okay, so that's all for this section. So in this section, we introduce a little bit about some basic operations or calculations for vectors, including addition and product. And for product of two vectors or scalar and vectors. For vectors product, we learned dot product and the cross product. They're completely different products. For example, a dot product, it results in a scalar. However, a cross product, it results in a new vector. Okay, so that's this lecture. Let's stop here.